What if I told you that for billions of years the moon has been hiding something from us, not just a shadow, but a secret written in stone and silence? Every night, we look at its bright, familiar face, never realizing that the other half has never looked back. What lies there? Ancient structures, alien whispers, or the forgotten scars of creation itself? The truth is far stranger than you imagine, because the dark side of the moon may not be as empty as we think.
The eternal mystery. Why do we never see the other side of the moon? Since the dawn of humanity, the moon has been a symbol of mystery, beauty, and fear. Always shining above us, it feels like a silent guardian watching from the dark.
Yet one question has haunted astronomers and dreamers for centuries. Why do we always see the same face of the moon, no matter where we are on Earth? This strange cosmic coincidence has inspired myths, theories, and even conspiracies about what could be hiding on the unseen side. Ancient civilizations gave the moon divine powers. They believed its hidden face was home to spirits, gods, or unknown forces that influenced the tides and human fate. Some called it the Dark Realm, a place where light never reached. What they didn't know is that the reason behind this phenomenon is far more scientific and far more fascinating. The moon spins on its axis at the exact same rate that it orbits the Earth, a phenomenon called tidal locking. Over billions of years, Earth's gravity slowed the moon's rotation until the two became perfectly synchronized. It's as if the two celestial bodies were dancing in a cosmic rhythm, forever locked in step. Because of this, we only ever see one hemisphere, the so-called near side. But that perfection raises questions. Was this balance always this way? What if, long ago, the moon rotated differently, showing more of its hidden world? Scientists have long wondered if something massive, perhaps a colossal impact, could have altered the moon's spin. And if that's true, what traces of that event might remain buried on the far side? Before space exploration began, humanity's imagination filled the void. Poets, philosophers, and astronomers alike speculated that the moon's hidden half might hold secrets beyond comprehension. Some thought it was a barren wasteland. Others believed it could harbor alien civilizations watching us from the shadows. Until the 20th century, the far side remained an untouched enigma, the ultimate cosmic mystery. As telescopes grew stronger, astronomers began to map every visible crater and plain on the near side. Yet the other half stayed in total darkness, a void of knowledge. It became a blank canvas for imagination, science fiction, and countless debates. Humanity was desperate to turn the moon around, if only for a second, to glimpse what had been hidden for eons. Then came the Cold War, and with it, the race to uncover the moon's secrets. The mystery of the far side became a matter of national pride, not just curiosity. Whichever country saw it first would make history, claiming the unknown in the name of science or dominance. Even now, the idea that half of our closest celestial neighbor remains invisible to us every night sparks wonder and unease. The moon, our eternal companion, hides something we can't see but feel is there. It's a reminder that even the most familiar things in our sky can still hold deep, untold mysteries. And what lies on that hidden face might just change everything we think we know about our closest cosmic partner. The tidal locking secret: how gravity controls the moon's rotation. To understand why we only see one side of the moon, we need to dive into the invisible power that binds it: gravity. The Earth's gravitational pull has shaped the moon's movement for billions of years. In the beginning, the moon spun much faster on its axis, but Earth's immense gravity created tidal forces that gradually slowed it down, like a cosmic hand gripping its motion. Over time, this process reached equilibrium. The same side of the moon now always faces Earth, a delicate balance known as synchronous rotation. This synchronization isn't unique to our moon. Many moons across the solar system experience tidal locking. But ours is special because of its closeness, its influence on tides, and its role in stabilizing Earth's tilt and seasons. Imagine two dancers locked in step, one heavier, one lighter. The heavier one, Earth, pulls the lighter, Moon, so powerfully that their movements become one continuous rhythm. That's tidal locking, a gravitational embrace so strong that one partner can never turn away. But this perfect balance came at a cost. The Moon's surface bears the scars of billions of years of gravitational stress. Its crust is thicker on the far side, suggesting that immense forces once reshaped it. Some scientists even believe the far side's unique terrain, more craters, fewer plains, is a direct consequence of this violent locking process. It's as if the Moon's hidden half endured more punishment, a rougher history than the side we see. And maybe, just maybe, that's why it looks so different. What makes this even more fascinating is that the tidal locking process isn't instantaneous. It unfolds over eons, meaning that long ago, ancient life on Earth might have seen different faces of the Moon rising and setting in the night sky. Imagine that, a time when humanity's oldest companion wasn't yet hiding half of itself. This revelation transforms the Moon from a static object into a dynamic storyteller of Earth's past. Every crater, every scar, every imbalance tells a piece of that story, a history written not in ink, but in gravity. Yet, even with this understanding, the far side remains out of reach to the naked eye. We know the why, but not the what. What secrets are carved into its craters? What truths are buried beneath its thicker crust? Those questions drove humanity to do the unthinkable, to send machines, and eventually people, to uncover the Moon's hidden face. And that's where our story truly begins, with the first daring missions that set out to photograph what no human had ever seen. The first missions that dared to reveal the invisible. By the mid-20th century, humanity had entered a new era, the space race. The Moon, once a distant muse of poets, became the ultimate prize in a silent war between nations. Both the United States and the Soviet Union wanted to be the first to uncover what lay beyond that hidden lunar horizon. The far side wasn't just a scientific mystery anymore, it was a geopolitical trophy. The technology of the 1950s, however, was fragile. Rockets exploded, guidance systems failed, and communication across space was a barely mastered art. The idea of photographing something that no human eye had ever seen was ambitious, even reckless. Yet the Soviets, driven by boldness and secrecy, pushed ahead with a plan that could change everything. Early attempts to orbit the Moon faced countless setbacks. Some probes missed their targets completely, others were lost in space forever. But failure only fueled determination. Each mission brought engineers one step closer to understanding how to aim, stabilize, and transmit data across the cold void separating Earth and its satellite. It's important to remember, at that time, the far side of the Moon was literally invisible to Earth's instruments. Radio waves couldn't reach it. No telescope could peek behind the lunar curtain. The only way to see it was to send something around the Moon, to make it turn its hidden face toward a mechanical eye. The mission that would achieve this had to be perfectly timed. It would need to pass behind the Moon, take photos blindly, and then transmit them back once it re-emerged on the near side. Every second mattered. Any mistake meant total loss, and another mystery left unsolved. Tension was enormous. The scientific community waited, the military watched, and the world held its breath. What would those first images show? A landscape scarred by impacts or something unnatural? When the Soviets announced they were attempting such a mission, the United States scrambled to catch up. The Moon had become a symbol of dominance. Whoever revealed its hidden side first would prove not just scientific superiority, but ideological victory. It was no longer just about curiosity. It was about pride, power, and control of knowledge itself. The Moon, for the first time in history, was a battleground of ideas. Then, in 1959, everything changed. The Soviets launched Luna 3, the probe that would finally turn the unseen into the seen. Humanity was about to meet the Moon's other face, the historic discovery of Luna 3rd October 1959. A small, uncrewed spacecraft named Luna 3 soared into space, carrying humanity's hope and its curiosity on a mission no one had ever attempted before. The Soviet engineers who built it knew the odds were slim. The slightest miscalculation could send the probe spiraling into nothingness. But if it succeeded, it would rewrite history. Luna 3 was equipped with 2 film cameras, an onboard darkroom, and a complex radio system to transmit photos back to Earth. Its mission: to orbit the moon, capture images of its far side, and send them home using analog technology, an almost impossible task in 1959. When the probe disappeared behind the moon, radio silence followed. For 40 minutes, Soviet scientists stared at their monitors in tense anticipation. The spacecraft was completely out of contact, isolated in the lunar shadow, orbiting the unknown. Some feared it had been lost forever. Then, suddenly, Luna 3 reappeared on the near side. The signal returned. The data began to flow. What it carried stunned the world. The first images of the far side of the moon revealed a landscape utterly alien compared to the familiar near side. It was rugged, covered in deep craters, and strangely devoid of the smooth Maria plains we see from Earth. It looked older, harsher, like a scarred face time itself had forgotten. The scientific community was in awe. For the first time, humanity had seen something truly new, a part of the universe that had remained hidden since the dawn of civilization. But the images also raised unsettling questions. Why was the far side so different? What forces shaped it that never touched the near side? Even with its grainy photos, Luna 3 transformed lunar science overnight. It proved that the moon's 2 faces were not twins. They were opposites, forged by completely different cosmic histories. And yet, no one knew why. Behind the triumph, whispers began. Some claimed the Soviets had found something strange, patterns or shapes in the craters that didn't look natural. The photos were low quality, easy to misinterpret, and that was enough to ignite endless speculation. To this day, Luna 3 remains one of the most daring and mysterious missions in human history. It was the moment when the moon's silence was first broken, and humanity realized that even our closest neighbor could still hide secrets far beyond imagination. Shocking differences between the near and far sides of the moon. When the first clear images of the far side arrived, scientists were astonished. The 2 halves of the moon looked as if they belonged to completely different worlds. The near side, the one that gazes down at Earth, was smooth and dark in many places, marked by vast plains known as Maria. The far side, however, was chaotic and ancient, covered in scars that seemed to tell a violent story. This contrast raised immediate questions. Why would one side of the moon have massive plains, while the other was a jagged wasteland? The early theory suggested that enormous asteroids had struck one hemisphere more frequently than the other, but that didn't explain the underlying geological differences, particularly the moon's crust. Measurements showed something startling. The crust on the far side is much thicker than on the near side. In some regions, almost twice as dense. That meant molten material from the moon's interior could rise and fill impact basins only on the near side, creating those dark plains we see from Earth. On the far side, the crust was simply too thick for lava to escape. But the question remained: why was the moon so uneven in the first place? Some scientists proposed that billions of years ago, Earth's gravity pulled more strongly on one side, altering its internal balance. Others suggested an even wilder idea, that the moon was once 2 separate bodies that merged after a slow collision. This two-moon theory paints a fascinating picture. In its early years, Earth might have had 2 natural satellites. The smaller one eventually collided with the larger, fusing together and creating the thick crust that defines the far side today. If true, it means the far side isn't just older. It's the scar of a cosmic accident that shaped the moon forever. The difference in appearance also affects how sunlight and temperature behave. The far side experiences colder extremes and deeper shadows, making it an even harsher environment. Without direct communication to Earth and with no smooth plains for landing, it became one of the most hostile destinations in our solar system. These differences also puzzled mission planners. The near side offered stable regions for landers and communication lines, while the far side was a realm of silence, both beautiful and terrifying. Every attempt to reach it meant venturing into a zone of radio darkness, completely cut off from Earth signals. And yet, these differences made it even more intriguing. Scientists knew that what lay there could hold answers not only to the moon's history, but to the birth of the entire solar system. The far side, untouched and ancient, became the ultimate time capsule, a record of cosmic history frozen in stone. To explore it would mean facing the unknown, both scientifically and psychologically. What if the far side held evidence of forces we still don't understand? What if the truth about our moon was stranger than anything we've imagined? Little did humanity know that beneath its mysterious surface lay something even more extraordinary. A formation so massive that it defied logic and gravity itself. Giant craters and unexplained formations. Hidden within the moon's far side lies a colossal scar, the South Pole Aitken Basin. Stretching over 2,500 kilometers in diameter and plunging 8 kilometers deep, it is one of the largest impact craters in the entire solar system. To put it in perspective, if you stood inside it, the curvature of the crater would vanish beyond the horizon. It's a wound of unimaginable scale. Scientists believe this basin was created by a titanic collision more than 4 billion years ago, possibly with an asteroid the size of a small planet. The impact was so powerful that it nearly shattered the moon entirely. Yet somehow, it survived, forever marked by this enormous crater. But what's truly mysterious is what lies beneath it. Data from NASA's Grail mission in 2019 revealed something shocking. A dense metallic mass buried deep under the basin, stretching for hundreds of miles. It was so massive that it affected the moon's gravitational field. Whatever it was, it didn't belong there. Scientists theorized that this buried material could be the remains of the asteroid that created the basin, a fragment of alien metal fused with lunar rock. But others weren't so sure. Some researchers noticed unusual magnetic readings, inconsistent with typical impact materials. Could this be evidence of something else entirely? The discovery reignited public fascination with the far side. Conspiracy theorists claimed that the mass anomaly could be an ancient structure, a remnant of unknown technology buried deep within. Of course, the scientific community dismissed such ideas, but even scientists admitted they didn't yet have all the answers. Adding to the mystery, several other strange formations were detected in the same region: domes, ridges, and circular patterns that didn't match normal geological behavior. Each new image seemed to raise more questions than it answered. Was this simply the chaotic result of ancient impacts, or the trace of processes we still don't understand? The far side's terrain tells a story of constant bombardment. Its craters overlap like scars upon scars, some dating back to the earliest days of the solar system. Studying them gives scientists a glimpse into a time before Earth even cooled, when our world was still molten and chaos ruled the skies. Yet, as we learned more, the strangeness deepened. The far side's magnetic fields behave differently from those on the near side. Some areas appear to trap particles in odd ways, forming microenvironments that seem almost alive in how they react to solar radiation. Even with modern data, the truth about the Aitken Basin remains elusive. What really caused such a massive, perfectly preserved impact? And what exactly is buried beneath it? The answers, locked in silence and shadow, may forever redefine our understanding of how moons and worlds are born. The crucial role of China's Chang'e 4 mission. For decades, the moon's far side remained a forbidden frontier, unreachable and silent. But in 2019, that silence was finally broken. China achieved what no other nation had, the first successful landing on the far side of the moon. The mission, Chang'e 4, named after the Chinese moon goddess, marked a turning point not only for space exploration, but for our understanding of lunar history itself. Landing on the far side was no simple feat. Because that region faces away from Earth, direct communication was impossible. To solve this, China launched a separate satellite, Queqiao, meaning magpie bridge, into a special orbit beyond the moon to relay signals back to Earth. It was a technological ballet, and it worked flawlessly. On January 3, 2019, Chang'e 4 touched down inside the von Karman crater, deep within the mysterious South Pole Aitken Basin. Moments later, its robotic companion, the rover U-22, rolled onto the dusty surface. For the first time in human history, wheels moved across a landscape no eye had ever seen directly. The images that followed were breathtaking. The far side was a world of deep grays and jagged terrain, bathed in alien sunlight. Every rock, every ridge told the story of cosmic violence and survival. But beneath that beauty, the instruments aboard Chang'e 4 were detecting something unexpected, traces of minerals rarely found on the near side. Spectrometers on the rover identified olivine and low-calcium pyroxene, minerals thought to originate from the moon's mantle, its deep interior. This suggested that the Aitken impact had been so powerful, it might have exposed material from layers buried miles beneath the lunar crust. It was the closest thing scientists had to a glimpse inside the moon itself. But discoveries didn't stop there. U-22 also measured strange reflections beneath the surface, areas where radar signals bounced back unusually strong. Some interpreted these as layers of ancient lava, while others wondered if there could be something more artificial. Meanwhile, Chinese scientists noticed another peculiar detail. The far side seemed unusually quiet, electromagnetically silent, almost eerily so. This made it a perfect place for radio telescopes, free from Earth's interference. Plans were soon discussed for building an astronomical observatory right there in the moon's shadow. The success of Chang'e 4 shocked the world. It wasn't just a triumph of engineering, it was a statement. China had opened a door no one else dared to touch, stepping into the most mysterious half of our celestial neighbor. And yet, as the data poured in, the public's fascination shifted. Alongside genuine science came speculation, fueled by strange photos, blurry shapes, and rumors of hidden structures. The far side's enigma was far from solved. In many ways, it was only beginning. Because where science finds silence, imagination tends to fill the void. Anomalies, signals, and the birth of conspiracy theories. Not long after Chang'e 4's landing, the internet erupted with claims that something unusual had been found. Online forums filled with enhanced images and videos supposedly showing structures or machines in the distance. Some pointed to a cube-shaped shadow spotted by U-22 in 2021, calling it the alien hut. Scientists, of course, dismissed it as a simple rock, but curiosity spread like wildfire. The moon has always been fertile ground for conspiracy. Ever since Luna 3 sent back those grainy photos in 1959, people have claimed to see towers, domes, or artificial patterns hidden in the far side's terrain. Most are tricks of light and shadow, the human brain's tendency to find patterns where none exist. Yet, that doesn't stop speculation. One popular theory suggests that an ancient extraterrestrial civilization once used the moon as an observation post. Others claim it's hollow, a kind of cosmic spaceship. These ideas might sound absurd, but they persist because of one undeniable fact. We still know very little about the far side. Adding to the mystery are the occasional reports of strange radio signals picked up by probes near the moon. In 2016, NASA's Lunar Reconnaissance Orbiter detected faint bursts of radio waves while passing over the far side. Scientists attributed them to cosmic background radiation, but to conspiracy theorists, they were proof of something communicating from the shadows. Then came U-22's radar anomalies, reflections that some interpreted as underground structures or metallic objects. Though the official explanation points to layered rock formations, the ambiguity only deepened public fascination. Every new photo became a potential clue in a cosmic puzzle. Part of this allure stems from how silent and unreachable the far side truly is. It's the only place in the solar system completely shielded from Earth's radio noise, a perfect location for secrets to stay hidden. Combine that with centuries of myth and mystery, and you have the perfect storm for the imagination to run wild. Even some scientists admit, the far side feels different. It's colder, older, and somehow lonelier. There's a sense that the moon's other face has witnessed things long forgotten, cataclysms from the dawn of the solar system that left their marks in craters and magnetic scars. The truth, however, is likely both simpler and more profound. The anomalies we see are reminders of how little we've explored, how easily we project meaning onto the unknown. The far side is a mirror, reflecting not aliens, but our own desire to find stories in the silence. Still, that silence hums with mystery. The farther we go into it, the more we realize that the line between science and wonder is thinner than we think. And as humankind continues to explore, one question lingers in every curious mind. What if, one day, the far side finally answers back? What NASA and other agencies really know for, as long as the far side of the moon has been studied, there's been one constant: secrecy, or at least the appearance of it. Since the Apollo era, NASA has collected thousands of hours of footage, countless samples, and an enormous amount of data, much of which has never been publicly released in full. That vacuum of information has only fueled more speculation about what might really be known about the moon's hidden half. During the Apollo missions, astronauts orbited the moon multiple times, and every orbit included a period of radio silence while passing over the far side. In those moments, all contact with Earth was lost. What the astronauts saw or heard during those dark minutes remains largely unspoken, a perfect breeding ground for mystery. Declassified mission transcripts reveal moments of tension. Apollo 10's crew, for instance, reported hearing strange whistling sounds while on the far side, a phenomenon later attributed to radio interference between spacecraft modules. But for the public, it became something else entirely: whispers of an alien signal, echoing in lunar shadow. NASA's official stance has always been clear. There's nothing unnatural on the moon. Yet, it's also true that agencies often keep raw data private for decades, citing national security or proprietary technology. The same applies to military satellites that occasionally pass near the moon, gathering high-resolution imagery that never reaches civilian eyes. In 1994, the Clementine mission, a joint venture between NASA and the US Department of Defense, mapped the moon in unprecedented detail. While much of the data was released, large portions were classified. The stated reason: military interest in lunar imaging technology. But conspiracy theorists took it as proof that something extraordinary had been found and hidden. Over time, both NASA and the European Space Agency have acknowledged that certain anomalies exist on the moon: gravitational irregularities, unexplained magnetic fields, and even mass concentrations under its crust. These mass cons are scientifically documented, but their exact causes remain partly mysterious. What's most intriguing is how carefully worded official statements often are.
Scientists talk about unusual densities, unexpected reflections, and non-homogeneous subsurface materials. It's the kind of language that invites more questions than answers. Some even speculate that governments intentionally downplay discoveries to prevent mass hysteria or to keep potential resources, like helium-3 or rare minerals, under wraps. After all, the moon's economic and strategic value is immense. Control over its future could mean control over space itself.
So what does NASA truly know about the far side? Probably more than they've told us, but perhaps less than we imagine. The truth, as always, lies somewhere between science and speculation, waiting to be uncovered piece by piece. And those pieces may already be emerging, buried within the moon's mineral secrets. Mineral discoveries that defy what we knew about the moon. When the Chang'e 4 mission analyzed the moon's surface, it revealed something astonishing: minerals that shouldn't be there. The far side appeared to contain traces of materials thought to originate from the lunar mantle, suggesting that ancient cataclysms had exposed the moon's deepest layers. This discovery reshaped our understanding of how the moon was formed, and possibly how the entire Earth-Moon system came to be. The presence of olivine and low-calcium pyroxene was particularly shocking. These minerals form under extreme heat and pressure, conditions found deep below the surface. If they were present on the far side, it meant that massive impacts, perhaps the South Pole Aitken collision, had literally torn the moon open. But the surprises didn't end there. Radar and spectroscopic analysis revealed strange metallic signatures deep beneath the crust, signals stronger than anything on the near side. Some scientists theorized these could be remnants of the asteroid that struck billions of years ago. Others suggested an even more intriguing idea, that the far side contains materials not native to the moon at all. In 2019, NASA's Grail mission confirmed a dense mass anomaly beneath the Aitken Basin, roughly 5 times larger than Hawaii's Big Island. Its composition? Unknown. The data pointed to something heavy, metallic, and ancient, yet chemically distinct from surrounding rock. It's as if a piece of another world is buried deep within the moon. Such discoveries reignited debates about the moon's origin. Did it form from a massive impact between Earth and another planet-sized object, as the giant impact hypothesis suggests? Or could parts of the moon, especially its far side, come from an entirely different celestial body captured by Earth's gravity? If that's true, then the moon isn't just Earth's companion. It's a cosmic hybrid, carrying the remnants of 2 worlds fused by fire. Every mineral fragment, every uneven layer, is a clue to that ancient collision. Beyond the scientific wonder, these findings carry profound implications. Certain lunar minerals could hold traces of elements unknown on Earth, materials formed under conditions we've never replicated. Some researchers even speculate that rare isotopes found there could unlock new energy possibilities, especially helium-3, a potential fuel for future fusion reactors. And yet, despite the groundbreaking discoveries, mysteries remain. How deep does the metallic mass go? Why is it perfectly centered beneath the Aitken Basin? Is it the remnant of an ancient impact, or something even older, from before the moon was captured by Earth's gravity? Each question leads to another. Each answer opens a new doorway. The moon's far side, once dismissed as lifeless rock, has become a geological and cosmic enigma, a puzzle whose final piece may rewrite the story of our entire solar system. But as scientists dig deeper into data and theories, one truth remains unshakable. We've only scratched the surface. What lies beneath may not just tell us about the moon, but about our own beginnings. How the far side can help us understand the origin of the solar system. The far side of the moon is more than a mystery. It's a time capsule. While meteor impacts, volcanic activity, and solar radiation have altered much of the near side, the far side has remained almost untouched for billions of years. It's as if it has preserved a frozen snapshot of the early solar system, waiting patiently for someone to decode it. Each crater on that surface tells a chapter of cosmic history. The density, depth, and chemical composition of those craters act like a geological diary, recording collisions from an era when the planets were still forming. By studying them, scientists can trace how the solar system evolved, from chaos and fire to the stable harmony we know today. The thick crust of the far side also offers insight into the moon's asymmetric formation. Why one side bears smooth plains while the other remains rugged could reveal how planetary bodies interact under tidal forces, lessons that apply not just to our moon, but to countless exomoons orbiting distant worlds. Some researchers believe that beneath the far side's crust lies a key to understanding planetary differentiation, the process by which worlds separate into layers of core, mantle, and crust. If scientists can sample that material, they might uncover clues about the Earth's earliest moments, when both our planet and its satellite were still molten and unstable. But the far side's scientific value doesn't stop at geology. Its radio silence, the absence of interference from Earth, makes it the quietest place in the solar system. Astronomers dream of building radio telescopes there, capable of detecting faint signals from the universe's infancy, light and sound from the time before the first stars were born. Such instruments could listen to the cosmic dark ages, a period invisible to our current technology. From that data, we could learn how galaxies formed, how gravity shaped the cosmos, and perhaps even find hints of alien civilizations whispering across the void. In a sense, the far side of the moon isn't just a place, it's a gateway to deep time. It connects us not only to the past of our solar system, but to the birth of the universe itself. The dust beneath its craters may hold particles older than Earth, remnants of the explosion that created everything we know. Every rock, every grain of regolith, carries a secret, the fingerprint of creation. To walk there is to step into history older than life, older than the sun, older even than memory. That's why the far side has become the focus of new international missions. NASA, China, and other agencies are planning robotic and possibly human expeditions in the coming decades. Each mission is a step closer to unlocking one of the last untouched frontiers. And maybe, when we finally hold a piece of that ancient soil in our hands, we'll realize that understanding the moon was never just about exploring space. It was about discovering our own cosmic origin. Myth, science, and the truth. We still don't know for centuries. The far side of the moon has been a canvas for imagination, a realm where myth, fear, and wonder intertwine. From tales of gods and monsters to theories of alien civilizations, humanity has always projected its deepest curiosities onto that hidden face. But now, after decades of science and exploration, we stand at the edge of truth. And yet, the mystery remains. We have seen its craters, mapped its shadows, and measured its composition. We've sent machines to touch its soil and rovers to roam its desolate plains. Still, every discovery seems to reveal another layer of questions. The more we learn, the more the moon seems to remind us how little we truly know. The far side teaches us that knowledge and mystery are not opposites. They coexist. For every piece of data, there's a sense of awe that science can't erase. The moon isn't just a celestial body orbiting Earth. It's a mirror reflecting the boundless curiosity of the human mind. Perhaps that's the true secret it hides. Not alien bases or ancient ruins, but the endless hunger to understand. That hunger has driven us from caves to stars, from myths to mathematics. The far side is both a mystery we chase and a reflection of who we are, explorers by nature, seekers by instinct. Still, there's something haunting about it. The way it hides its face, always turned away, as if guarding a secret too vast to comprehend. Maybe the truth isn't about what's there, but what it represents. The idea that some mysteries are meant to be discovered slowly, piece by piece, generation by generation. And yet, the story isn't over. Every year, new missions prepare to return, new telescopes listen for whispers in the silence, and humanity continues to look upward, wondering. The moon's far side still watches us from the dark, patient, ancient, and silent. We are closer than ever, yet still in the dark. The moon keeps her secrets well, but not forever. One day, perhaps soon, the far side will speak. And when it does, it won't just tell us about the moon. It will tell us about ourselves, about where we came from and what we're still becoming. Wanderers in an infinite universe, forever chasing the light of understanding through the shadows of the unknown. Because maybe in the end, the real mystery of the moon isn't what it hides, it's what it reveals.